Hello, friends. Once again, welcome to the session. As part of this session, we will talk about what is artificial intelligence, what kind of projects can be accomplished in artificial intelligence, what is generative AI, what kind of projects are accomplished in generative AI, and we'll understand a few nuances of generative AI. Yeah. So this is going to be our journey, and this will help you all get a gist of what's happening in the world of AI and generative AI. Yeah. So let's get started. And once again, welcome everyone to this session. We all know that the term called generative AI is buzzing in the business world. A lot of AI experts believe that generative AI is going to be the next big thing. It's already the next big thing, I should say, at this point of time. Right. So we'll take this discussion further and try to understand more. But even before we proceed further, I would like to quickly give you all an introduction about myself. Hopefully it will come up. Yeah. So this is me. My name is Bharani Kumar. I am CEO and founder of two companies. So one is called as 360DigiTMG, which is into training services. Another is AI Sprite, which is into projects. These are the two, organizations on which I serve as a CEO, obviously, because I'm the founder as well, right? And I also work as a chief data scientist on a lot of other companies. And I serve as a CTO, Chief Technology Officer, on one of the startups. Yeah. That's in short about my profile. I hold a master's degree from Indian School of Business, and I hold a master's degree from IIT. I have now it's 19 plus years of experience. I need to update that. I work with companies such as HSBC, ITC Infotech, Infosys, and Deloitte. Post that, we formed our company and we have been doing a lot of projects since then. If anyone wants to connect with me, this is the link. However, I should also tell you that you would not see the option called connect because after you cross 30,000 connections, or if you get 30,000 connections, then LinkedIn will disable the option called connect on LinkedIn profiles because that's the maximum connections which LinkedIn allows. Beyond that, you would only see an option called follow, and you'd be able to follow me. And then if you follow me, I think you'll be able to send messages as well. Yeah. So I have 52,500 followers at this point of time. Right. Okay. So that's a brief intro about myself. As I've told you, there are two companies. I'll briefly talk about a company which is called as AI Sprite. AI Sprite. AI Sprite is our AI services company under the umbrella of which we do a lot of projects. Okay. What kind of projects do we do? I'll delve into that and I'll briefly talk about that. Yeah. So we do projects in the space of AI and also generative AI. We have 160 plus people who are working with us, and we formed this company in 2017. We have been successfully implementing AI solutions in different countries. We are not just confined to India alone. We do projects for customers in Malaysia, Canada, Middle East, etc. And we also have offices in India in 4 different places. So that's in brief about what is AI Sprite. And let's talk about the major projects that we have delivered. Yeah. By the way, we have done projects for Volvo Trucks. We have done projects for Korean Airlines. We have done projects for Coca-Cola, so on and so forth. Right. So let me now take you guys to the journey of the projects that we have accomplished. Then we will come to the discussion, other discussions. So let's get started with the first project. whenever you work on any project, you should first understand the business problem. Okay. This is a project which we have done for one of the leading automobile companies. And this is a fixture on which the engine chassis is being kept. And then now this gentleman is clamping, right? He is clamping the workstation. But first thing is you need to understand what is the business problem here. Business problem. What is a business problem? If incorrect clamping sequence is followed, if people are doing incorrect clamping sequence, then in the quality inspection process, which happens at the end, when the truck is completely assembled, people will do a quality inspection. During quality inspection, they will figure out that something is wrong. Probably the engine chassis is not assembled properly. Probably it is slightly bent, right? If that happens, they are going to again dismantle, open the, components, and then they'll again fix it. They'll fix the mistakes. This will increase the cost of poor quality. Increase cost of poor quality, meaning more time you should spend again to redo the things, again open, again fix it, again close it. Yeah. So that will increase the cost of poor quality. Now we need to look at how many hours and for how many trucks they are figuring out that something went wrong as part of their clamping process. Okay. And then you'll come to know how much extra effort you're spending, and that effort translates to money, cost. Okay. So we need to fix this issue, obviously. How did we fix it? To fix this problem using artificial intelligence, you first need data. So we went there to this manufacturing plant, then we have collected the video. We have captured the video using our mobile phones, etc. Then we came back because CCTVs weren't sufficient. CCTV in this manufacturing plant was not there exactly on the top of this clamping station, right? It was somewhere at the side. So we had to capture the video right from the top. Hence, we resorted to our mobile phones. We just captured the videos as part of data collection. And those videos, we split them into images. Every video is collection of multiple images. So we split that into multiple images. And on each image, we have hand annotated. Like, for example, we put a box like that on that image, and we'll say this is clamp 1. This is clamp 2. This is clamp 3. This is clamp 4. This is clamp 5. In that way, we capture all the clamp details. Then we train the algorithm to teach that if the person first closes this clamp 1, then 2, then 3, then 4, then 5, only then it's a right sequence. If not, it is a wrong sequence. You teach the machine learning algorithm. Once your algorithm learns, you have to give that to the customer. How will you give it to the customer? Will you give the code? You need to write Python code like this. Would you give that code to the customer? No. What you do is you deploy the solution. Where will you deploy? So what we have done is we have used IoT device, Internet of Things device. Okay. We used something called as Raspberry Pi. Of course, we put a case which helps it serve at industry grade, because there will be a lot of heat in the manufacturing plant. Temperature will be very high. If you put your regular sensors without, casing them, then it will cause damage. So we put our algorithm into Raspberry Pi. Okay. And then Raspberry Pi would continuously keep monitoring this video. Would continuously keep monitoring the video. And whenever wrong sequence is followed, if a person is following a wrong clamping sequence, okay, then the algorithm would say that, hey, this is wrong sequence. And it will glow the entire floor in red color. The entire floor will be in red color. We first resorted to sound-based alert mechanism. If it's sound-based, I mean, if a person is doing wrong sequence, wrong clamping, then you give a buzzer, some kind of a beep, loud sound. But the floor, manufacturing floor was so noisy that people weren't able to hear that. So we decided to go with a light-based system wherein it will glow the entire floor in red color. That is an indication to the supervisor that something is going wrong here, and the supervisor will go and try to fix this. This is how we built our AI solution. Okay, hope you are getting some sense, right? So we have automated this process. Supervisor need not manually stand at each and every clamping station, right? There were close to 13 or 14 clamping stations here. Okay, so hope you got a gist of this project. This discussion will help us, friends, because then you'll be able to differentiate between what is artificial intelligence solution and what is generative AI solution. The next solution or the next project which we have done is for one of the leading steel manufacturers, sorry, not manufacturers, steel distributors in India. So this particular client, to differentiate themselves from the other competitors, they thought rather than just distribute the steel, rather than just distribute the steel rods, we will also cut the steel rods and bend the steel rods and give it to the construction company. Traditionally, what happens? You transport these steel rods, which are of standard 12 meters size, standard TMT steel rods would be of 12 meters, standard ones. However, traditionally what happens, you transport all these steel rods to the construction site. And at the construction site, what do? They unload all these from the truck. And then at the construction site, they do the cutting and bending of the steel rods. You'll have pillars, you'll have slab, you'll have various construction components where you need steel, right? So you're going to cut and bend the steel rods at the construction site. As opposed to that, this specific customer for whom we did this project, they thought, let's, cut and bend the steel rods at our, manufacturing plant, and then we will send it to the construction site. So that's how they differentiated. So they don't just transport the standard 12-meter rods, but they cut and bend to suit the customer requirements, the construction company's requirements. Then they're going to transport. So what is the business problem? What did I say? I told you guys that we first need to understand the business problem. If you do not understand the business problem, you can't do anything, right? You don't know whether you have to go with artificial intelligence or generative AI. So what did we do? Okay. What we have done is we try to identify the business problem. What was a business problem? If a customer needs, say, 10 meters steel rod like this, okay, and then wants 3 meters steel rod. This is, say, their construction architecture diagram, the drawings. And then say another 10 meters like this. Okay. Maybe another 1.5 meters like this, another 1.5 meters like that. So assume that this is how the drawing is, a small drawing for our understanding. So what the workers at this particular plant do is, if they want 10 meters, they take 12-meter rod, they cut it into 10 meters. If you take a standard 12-meter rod, okay, steel rod, and if the entire length of this is, say, 12 meters, and if you cut it as 10 meters, assume, then the remaining part, which is 2 meters, would be called as offcut. And what do? This small component, they take it back and put it into the inventory. Okay. They put it back, they place it back into the inventory. Since they're going to place it back into the inventory, it will lie there. And no one is recording these details. That we have a 2 meters rod in our inventory. No one is recording that. They just take the 2 meters, they just dump it in the inventory. If they want 3-meter rod, once again they take the 12-meter rod, they cut 3 meters, and from 12 meters, if you cut 3 meters, the remaining 9 meters, again, they go and keep it in the inventory. No one is counting this. Again, if you want 10 meters, again, you go and take 12-meter rod, cut it. Okay. And if you take the 10 meters and remaining 2 meters, again, put it back in the inventory. If you want 1.5 meters, again, they go and take 12-meter rod. They don't go and check their inventory for the offcuts. They again go take the 12-meter rod. They take 1.5 meters, remaining, they put it back in the inventory. And the number of offcuts keep on increasing in their inventory. It gets piled up. And the customer here, when they realize that we don't have inventory space, okay, in our godown, we don't have space to place the new rods. That is when they take all these offcuts and they sell it as scrap. All these offcuts eventually are sold as scrap. And they don't even get the money, which is equivalent to the money they spent in purchasing these 12-meter rods. They purchase all the 12-meter rods from steel manufacturing company and they distribute it. They are steel distributors, not steel manufacturers. It's a loss, right? All these offcuts are selling as a scrap for lesser money than what they have purchased. They would have purchased these 12-meter rods for by spending some money from the steel manufacturers. Even that money they don't get. It's a loss. That's the business problem. They're incurring losses, not losses, but they're losing out money there. So we asked them, hey, why is it in this way? Why can't you record it? They were saying that the people who cut and transport these steel rods to the inventory are uneducated. Even if we give them probably an iPad or some kind of a pad or a mobile on which they are expected to enter the details, they don't do that. Okay, one is they don't know how to operate. One is they don't have the intent. They don't want to do that. Then we told them that, okay, we will solve the business problem. And you know what we have done? we have placed, we have captured the videos again. We had annotated every steel rod like this, right? That this is 10 meter, 10 mm, 12 mm, 8 millimeters, right? That's the diameter. And also we have captured the length. We captured the, videos on the other side also, and we captured the length as well. So we captured both diameter as well as length of each and every steel rod. So once you understand the business problem, the next step is to perform data collection. So we went and collected the data. After collecting the data, we have labeled these things. Manually, we have figured out what is the diameter and length of the steel rods in the videos which we have collected. So in data collection, we collected videos. Those videos were split into images. Okay. And images were annotated. Annotation happened. That is labeling each and everything. Then we trained our algorithm. Trained machine learning algorithm, which will learn the patterns, right? Next time when there is a new image or a video, it would be able to figure out that, okay, this is 8 this is, 10 this is 12 in that way. And it will automatically count how many such steel rods exist. And what is the length? Because we take the, video from the other side also. Then once we trained it, you cannot give the Python code to the customer, right? You have to give the solution in an easy manner. So what we have done is we have placed this algorithm in mobile device, in mobile application. And that's called as edge computing. In the previous scenario, we placed it on Raspberry Pi. That is also called as edge computing, and we deployed on edge, right? So we put it on the mobile, and then we gave it to the customer. So next time, how would customer use it? They'll just take their mobile, they just walk around. Okay. And by the time they reach the end, they will have the details of how many steel rods exist, of what diameter, what length, all these details will be there. Okay. Of course, when I post such videos for our marketing purpose, we take the customer consent. This video also we sent it to the customer. We told, hey, this is what we want to promote on our social media. Customer told, okay, show only diameter, don't show the length. So in that way, customers are going to control you on what information you can post on social media. Hence, I didn't put the other part of the video, which also captures the length. Yeah. Next. Story did not end there. Okay. It's a story, real world story based on true events. So what we have done then is, once they get the count of the steel rods, diameter and length, then they have to supply these details to the optimization algorithm. So it's combination of your, object detection, where you're detecting what is there in the image, and it's a combination of object detection and optimization algorithm, right? This optimization algorithm will then tell you that for your next construction drawing, where you need 10 meters, 3 meters, 10 meters, 1.5, 1.5 meters, steel rods, it will tell to complete this 10 meters, 3 meters, 10 meters, 1.5 and 1.5, right? So to complete the cutting and bending of the steel rods for this construction, you need to take, two 12-meter rods. In the inventory, if you have, say, 3 meters, then it might say you need to take two 3-meter rods. In this way, it will also tell you what is the most optimal, usage of your inventory so that it minimizes the scrap. Okay, so that it minimizes the scrap. If the offcuts get reduced, then it will minimize your cost. What cost? Inventory cost. This is how you need to start from understanding the business problem to actually giving the solution to the customer and you need to help the customer meet the business objective. Again, these are all true events. I'm sure there will be a lot of vegetarians here who is attending this session. For y'all, probably the next use case will be a little tricky, but yet we will go ahead and discuss that. We have done a project in the space of poultry. All these are very interesting things, friends. Very interesting things. Now here, I would first get started with the business problem. You can watch this, but I'll keep explaining the business problem while discuss or while you guys see this. What is the business problem here, right? What happens is usually when the chicks are farmed, it's like a farming only. Vegetarians might not like it, but it's called as farming. Okay, so what happens in farming? This is a thermal camera. Okay. So what happens is, play this again. And we will stop here. Okay. The typical farm lasts for 45 days. So day 1, day 2, day 3, in that way. The chicks are grown for 45 days. Say number of days is on x-axis. And on y-axis, you need to monitor the weight of the chicks. Is it 1 kg? Weight in kgs. Is it 1 kg? Is it 2 kgs? Is it 3 kgs? So on and so forth. Yeah. Typically, supposedly, if a chick is reaching 2.2 kgs, then it's good to sell the chicks. And typically it takes 45 days, it seems, for the chick to attain this weight of 2.2 kgs. Now, what also happens is after 30 days or after 35 days, the chicks eat so much of feed, right? Too much of feed that it eats into your profits. These chicks eat huge amount of feed and a lot of money is spent on feed. And the more number of days it takes to reach 2.2 kgs, more money you will be spending on their feed. So it will eat into your profits. That's the business problem. So profits were shrinking because there is no one who is measuring the weight of the chick continuously, right? You also know for a fact that sometimes chicks might hit 2.2 kgs or attain that weight by 40 days, but you're not monitoring that. So that's the business problem. So once we understood the business problem, what did we do? So now that you understand the business problem, the next step is to go and do data collection. So as part of data collection, we have gone ahead and we have captured the videos of these chicks. For all the 45 days, we captured the videos, my friends, for all 45 days. And when we captured the videos, we brought those videos and then we split those videos into images. And in each image, there were chicks like this. And what did we do? We have done annotation or labeling of these images. So we would put a bounding box like that. This is called as bounding box. Using a tool called as RoboFlow, we did it. So once you put a bounding box, you label on how old the chick is. Is it 1 week old, 2 weeks old, 3 weeks old? We label it. After you label it, after you label the age, you also make the people in the farm weigh these chicks. As part of data collection itself, you capture the videos and you record the details such as how old the chick is, or let me mention age of chick. Then we capture the weight of the chick. We take those chicks, put it on the weighing machine and do it. So the weight of the chicks is captured. And using the thermal cameras, we also were able to capture the temperature. Okay, I'll come to the temperature thing later, because temperature real time you can capture. Okay, I'll talk about temperature later. I'll just make a note of that. After this annotation, then you give these for training purpose. Okay, you supply to your machine learning algorithm where training happens. What do you mean by training? It's like teaching. Okay, you say teach your kid 3 tables. 3 ones are 3, 3 twos are 6. In that way, you teach your kid, assume. Then you conduct a test on 3 tables. You say 3 by 3 is how much? Your kid will say 9, because the kid has already learned that particular pattern, that 3 multiplied by 3 is 9. In that way, you supply all these images and say that if you see a chick of this size, it will be 3 weeks old and the body weight will be so much. In that way, you teach. Okay. Once the teaching is done, then you have to give the algorithm to the customer, because customer should use that. Will you give all the Python code? No. So what we have done here is, once again, we have used edge computing, edge device. And this time it was again Raspberry Pi, or I'd put it as IoT, Internet of Things, right? Raspberry Pi is what we have used. Of course, we have done the proper casing so that we don't damage it. And from there on, the video was getting captured. We told that entire video, if we want to send it to the server in which we have our, model, then it will be challenging, because all these farms will be in remote areas where internet connectivity will be very bleak. Correct. So what we have done is we told that every 15 minutes, we will take an image. Image is of smaller size, right? In comparison to video, we will take an image. We will process that image here itself. Okay. Only the information such as how old the chicks are, what is the body temperature of the chick, and what is the weight of the chick, only that information we will send it to our server. And we will place it in the database. On Amazon Web Services, we took a server on cloud, and there in the database, within a table, we were recording the details. This table contained the details such as what is the date, what is the time, and at that day, on that day, at that time, what was the age of the chick. Okay. what was the body weight of the chick, and what was the body temperature of the chick. All these details were captured. Okay. And these details would be given to the customer in this visualization format, in this chart format. And as soon as majority of the chicks reach 2.2 kgs, we send an alert to the farm owner. To that chick farm owner, we send an SMS alert saying that, hey, my dear friend, you need not wait for 45 days. It is, say, 37th day now, and already your chicks, on an average, majority of the chicks are already at 2.2 kgs. So you can sell the farm. And these 8 days, you need not wait until 45th day. You can sell your chicks now itself. And then you will save money. You need not give feed to the chicks for the next 8 days. Sell it. Okay. Then we also have the thermal camera. Let me show you that. The thermal sensors, the thermal cameras would real time continuously keep giving us the details on what is the body temperature of the chick. So body temperature of the chicks were also getting captured real time, once in every 15 minutes. And that information also was being sent to the database, and we would continuously real time keep giving the report to the farm owner. If the body temperature crosses, say, 40 degrees Celsius, we would quickly alert and say that, hey, chicks' body temperature is increasing. Majority of the chicks, by the way. That's the information we give, not for each and every chick. This is all going to help them. If the body temperature is increasing beyond a temperature value, if you send an alert, then the farm owner will quickly go and fix it. He'll probably take a veterinary doctor along. He'll say that, hey, check whether there is any disease for the chicks, which will spread and kill all the chicks. Yeah. So this is yet another interesting problem that we have solved. In this way, the list of projects will go endlessly. We captured on a conveyor belt when the eggs were being sent. We captured whether it's a white egg or a brown egg. Is there any crack on the egg? Crack detection. Is there any stain? Because when you supply the eggs to 5-star hotels or 7-star hotels, they expect the egg to be clean without any blood stain or without any other stain. Right? So all those things are also monitored. Yeah. So it was an immense learning for us. And for all these business problems that we have solved, we needed not just the technical knowledge, but we also needed the business knowledge. Only if you have business knowledge, you'd be able to do that. Technical knowledge, you get trained, you watch videos, whatnot, and then you gain, say, technical knowledge. But to gain business knowledge, you need to work with the customer. You need to work with those stakeholders. You need to daily interact with them, understand how their business works and all that. Only then you'll get the knowledge. Hence, I keep telling that if you work on projects which are there on websites such as Kaggle, etc., you would not gain sufficient business knowledge, because to gain business knowledge, you need to work on real world projects. Okay. You need to go and do an internship with those companies which work on real world projects. Otherwise, there's no question about you learning these things, right? All this information which I've given until now, do you think you would have gained by taking a project from internet and then working? No way. And people who just provide videos on YouTube, etc., their job is to just give you some bookish knowledge, which might not help you. Real world data, real world business problems are really different. Very different for that case. Okay. For all those people who are aspiring to get into the field of AI, after getting trained by those people who actually work on projects, get trained by them. Okay, it will help you immensely. Then work on the real world projects. That would help you clear the interviews. Otherwise, there is no way. You'll just have some knowledge. You'll not be able to do anything with that. Next project. There are quite a few projects and we have time as well. We will talk about one more project. We'll quickly take a small break. Then we'll discuss about the other projects. Then we will discuss what is the difference between AI and generative AI. And then we'll talk a little bit about generative AI. So just hold on. Let's discuss about one more project here. This time it's not about video or images. It's about something else. Let's talk. So let this video go on. I also wanted information about a few sensors, so I just did this. Okay. What is the business problem? Again, we are not going to do AI or generative AI stuff. We are not going to build solutions for fun. Okay, there's not research to do things for fun. Yeah. There is going to be real world business problem and your job is to fix that. Let's see what this particular project is all about and what was the business problem. The business problem here was that the specific customer that we are talking about here, again, uses machines to do some kind of cutting of steel rods. And they use a machine called as Prima 13. Prima 13 is a machine which is procured by this customer from Germany, from a company called as Schnell Group. I think FTH. No, Prima 13. Yeah. So this is the company which is based out of Germany, and these are the machines, right? These are the exact machines. Yeah. So these machines do a lot of work, like they bend the steel rod like that, they cut it. Yeah. Hope you got some gist on what happened. Now, these machines have a lot of sensors, and these sensors give you a lot of information. Okay, like they have proximity sensors, hydraulic pressure sensors, spindle speed, load cells, coolant temperature, vibration. Machines vibrate, machines make weird sound. So all these sensors data is what we get. Keep that aside. So what is the business problem? I just gave you a quick brief about the machine called Prima 13. What is the business problem here? Business problem is that the machines fail unwarranted, unplanned. So there are two kinds of breakdowns, or I should say downtime. Downtime means you're not using your machine simple. That's called as machine downtime. One will be planned. Planned means you do maintenance, you do service. Like if you have a bike or a car, what do? After a few kilometers, you give it for service, maintenance. They'll change the oil, they'll do the complete maintenance of your vehicle and give it back. That's called as planned downtime, planned maintenance. You're not using your vehicle while it's getting serviced, right? In that way, machines also need servicing. And the planned service will be there, like every 2 months, we will have the technician who will come, who will, check of whether all components are working well or not, and then leave. And also you have unplanned downtime. This is dangerous. Unplanned means suddenly machine will stop working. Then you'll figure out why is it not working, which component failed, right? What issues are there, and then you fix it. That's called as unplanned downtime. So what do you do with unplanned downtime? We want to reduce it. So the business problem is that unplanned downtime was on the rise. Unplanned downtime was increasing. So what is the next point? You need to go and collect the data. Data collection. Here, the data which was collected was in this format. You'll take the date, you'll take the time, and you take all the various details such as what was the proximity sensor value, what was the hydraulic pressure, what was the temperature, what was the vibration value, what was the sound value in decibels, so on and so forth. You capture all those details. And you capture one most important variable or column information, and that is on that day, at that time, while these were the values of different sensors, was the machine working or was it down? Was it up and running? Was it working as usual or did it fail? Up means it's good, machine is good. Down means machine failed. These details we capture. Okay, these details you get it from the machine only. Prima 13 gives you a lot of detail. But did it fail or not? This information someone would have manually captured. Okay, whenever machine goes down, the technician will make a note that machine went down at 7 or 8 a.m. Then again at 8:30 a.m., the machine started working. That means the downtime was 30 minutes. Such details they capture. And when machine failed at 8 a.m., what were the different values? What were the values of all these different sensors? This information we capture, and all these are called as inputs. All these sensors, data, date, time, all these is called all these columns would be called as inputs. And you have one column which is called as output. Okay. Why? Inputs are denoted using X, Y in that way. Output is denoted using Y. This data you captured, you do something called as pre-processing and all that. I'll not get into that. Data pre-processing, preparation and all that. And then you give this data to your machine learning algorithm. And the job of your machine learning algorithm is to learn the patterns between your inputs and output. When the machine failed, you know that machine failed, but what were the inputs when your machine failed? This information, these patterns, your machine learning algorithm will learn. You would have written Python code and all that. Obviously, now if you want to give it to your customer, the algorithm, the AI solution is built using machine learning. If you're confused on what is this AI, what is machine learning, we'll get there. We'll get there, trust me, in some time. Once we are done with all these business problems, we'll get there and have some kind of theoretical conversation. Okay, then what happens is you deploy the solution, you give the solution to the customer. That's called as deploying. To deploy this time, we used Amazon Web Services, AWS. Okay. And we have given a user interface to the customer. So the customer can just click on run and it will run. It will take the data, it will run, and it will quickly predict whether your machine will fail or not, even before it fails. That is what is prediction, right? So it will tell that your machine will fail in the next 1 hour. Your machine will fail in the next 2 days. Such details will be given. Okay. And we started giving such details to 2 people. One is we started giving alerts on when will that machine fail to the technicians. These technicians will go and check. They'll go and inspect whether the machine will truly fail or not. Is that a right alarm or not? Okay, let me clear this and explain you in a better manner. Okay, let me go here. So the technician will go and check whether the machine, technician will get an alert that, hey, your machine might fail. And then quickly the technician will run and try to check which component is faulty and they'll try to fix it. If it is a true alarm, if it's a true event, I got an SMS. I'm a technician. That machine might fail. So I'll go and quickly check. Yeah, this component is faulty. I'll fix it. If the technician feels that it's a false alarm, wrong alarm, I got an SMS that the machine might fail. But when I went and checked, everything was good. So it's a false alarm. This information also we need to capture. Why? Take this as an example. You taught your kid 3 tables, 3 ones are 3, 3 twos are 6, 3 threes are 9. And you ask your kid what is 3 threes, and your kid says 3 threes are 10, which is wrong. Why did your kid answer incorrectly? Because the kid did not learn it properly. Same is the case with machine learning algorithm also. It didn't learn that pattern well, and it gave a wrong alarm. So you have to retrain your algorithm. You have to retrain your algorithm. That's how it works. We also sent this information on which machine will fail, which component might fail. We also send that information to the inventory management. And what is the job of this inventory team? They will go and procure those components which are most likely to fail. Those components which are most likely to fail in the next 1 month or 2 months, they go and procure it, purchase it, and keep it readily in the inventory. Just in case that machine fails and that component fails, quickly you can replace with a good one, so that the unplanned downtime of machine reduces. Okay. Now I'll play this video. Watch it. We have done a lot of interesting things for different stakeholders. You can run the algorithm, full algorithm once, and you can do an incremental run. That means, say, you took the data for the last 3 years and you started using, but there is new data which is getting captured. Maybe for the next 2 months, there is new data which is captured. Okay, then you can do that incremental run. It will also tell you what components might fail. For the technical team, also there are different reports. For different stakeholders, we have given different reports. What is the probability of failing? Which component might fail? Is that a right prediction or a wrong prediction? Those details also they can input there. For the advanced machine learning users also, we have given a UI. And if you observe carefully, there is a URL here. That URL is pertaining to cloud. We use Amazon Web Services to deploy the solution. Customer just need to type in this URL, but this URL also can be converted into some text, right? Like prima13failure.com. We can create such URLs. So I believe you got good insights until now, but trust me, once again, technical knowledge and business knowledge both are important. Technical knowledge you gain by getting trained through 360DigiTMG, our company, which is into the space of trainings. And you also need business knowledge, right? And that is something that you gain by working on a real world projects through our company called AI Sprite. Combination of these two will help you. There are a few more projects and use cases which we're going to talk about. Certainly we need to talk. And then once we get enough understanding, we'll go and scratch the surface of artificial intelligence and generative AI, some amount of theory, and that would probably help us position better. Let us now talk about a few more projects, and trust me, these learnings are extremely rare. Yeah, whatever you are learning is the best, if you ask me. Because I'll be when I explain about each and every project that we have accomplished using AI or generative AI, I'll also bring in some business flavor to it on what kind of thinking goes into these kind of projects. And that will help you, right? It'll be a lifetime learning, trust me on that. And each of these projects probably took us anywhere between 4 months to 1 year. And a few of the other projects took us more than 1 year. So that amount of knowledge and learning through our experiences and mistakes that we have done, we are reducing that into probably 2-3 hours, and then we're trying to disseminate the information to you all. Enjoy. Okay, so there is yet another project. This project we have done a few years back, and this is something that we have done. Someone sending messages. I don't really find time to reply to each and every message there, but yeah. Okay. What is this project all about? But while this video also goes in the background, what is the first thing that we need to worry about? The business problem. Okay, first let's understand who this client is here. This customer manufactures pallets. Pallet manufacturer. Okay, and they manufacture wooden pallets, plastic pallets, etc. And those pallets which they manufacture are shipped or rented, leased to different other customers. They rent or lease to companies such as Amazon, Coca-Cola, etc. They have Instacart, Flipkart. These two are Indian specific companies. In that way, they have a lot of players. Okay. I'll explain about the pallets thing. So when you rent or lease, you have to ensure that you supply good quality pallets. Obviously, right? Damaged pallets, you should not ship it. If you supply damaged pallets, what would the customer do? Just think about this. This particular manufacturer, say, transports, and say Amazon places an order for 100 or 1,000 pallets. Say Amazon says that I want 1,000 pallets for the next 6 months. Please supply. Then this pallet manufacturer would transport in a truck. They'll use truck. They will load the truck with all the pallets, and they're going to transport. They'll transport from their nearest inventory to Amazon. And out of 1,000 pallets, if 900 pallets are good, Amazon will take those 900. Remaining 100 which are damaged, what will the customer do? They'll say, hey, these are damaged, take it back. So again, these 100 pallets which are damaged, you need to transport it back to your inventory. Transportation cost, customer is unhappy, customer wanted 1,000 and you could only cater to 900, another 100, either you again transport it, which is again increase of transportation cost. Or if the customer wants it immediately, customer will place an order from some other manufacturer, from some other pallet distributor. You lost the business. You lost the faith of the customer. Unnecessary transportation cost. Why all this? Because they were manually, all these workers were manually asked to inspect these pallets. So let me show you what happens when it comes to this pallet, right? So I'll take a stack of pallets somewhere. Yeah, I take this as an example. So what happens usually is all these pallets after the rent, after the lease, say Amazon says that I need these pallets for 100 days. After that, they send you back. Okay, those pallets. And at the, why is this not working? Yeah, at the unloading area, what your workers will do is they'll unload all these pallets which Amazon has sent you back, and they manually inspect, and they have to segregate. Okay, manually inspect and segregate. As what? Good pallets, those pallets which need some amount of repair, and pallets which are damaged beyond imagination. So pallets which are damaged beyond imagination, you need to dismantle them. So good pallets, out of all these pallets, good pallets, you place it here maybe. Those pallets which need repair, you put it here maybe. And those pallets which have to be dismantled completely, you put it somewhere else. You segregate it. Okay? Manually it is done. If it is manually done, chances are very high that something which repairs, small repair also, you'll put it at good. Someone which needs small repair, you might go and put it in dismantle. So all these kind of issues happen. To counter this, we have come up with our AI solution. What did our AI solution do? Okay, so this is the business problem. Incorrect segregation of pallets in the inventory because it's manually being done. So that's the business problem. Remember, always you need to start with a business problem. If at all you don't understand the problem clearly, then you'll not be able to proceed further. Once you understand the business problem, what is the next step? Go collect the data. For data collection, what we have done is we have placed cameras on 4 sides. We placed one camera here. I'll call it as C1. We placed another camera on this side. I'll call it as C2. Another camera was placed on this side, which is called as C3. And the fourth camera was placed here. Let me call it as C4. On the 4 sides of the pallet. So what will happen is when all these cameras capture the data, you get the data typically. You take that data again. We actually captured the videos. Videos were split into images, and each image we have hand annotated. How did you annotate? We annotated in this way, wherein we select this part and we say repair. Okay. Then we select this part and we say dismantle. It's completely damaged. Maybe we select this and we say dismantle. We just highlight this and say it's good, right? That's how we annotate. And once it is annotated, you supply to your machine learning algorithm, which will learn the patterns in the images, right? If the image is like this, what do we do? If the image is like that, how should it classify, etc. Then you deploy. Where did we deploy? We deployed it on cloud AWS. Okay. And these 4 cameras, and we have also placed a television set here. A big television set. Screen. TV screen. On this screen, real time, this image will come up. Of all these different pallets, and it will quickly tell which one is damaged, which one needs repair by looking at all the 4 sides. You have 4 cameras on 4 sides. This camera will look at this portion. The C2 will look at this portion. C3 will look at this portion. C4 will look at the portion here. And it will quickly determine whether any of the pallet is damaged. Does it require a repair? Should it be dismantled, or is it good? Into 3 classes. Good, damaged, good, repair, dismantle. These were the 3 classes. Sun is beating hard. Sun is coming and going. That's why the glow here. Okay. And then this is fine, but what about the top and bottom? Okay, what about replaced camera to take the other side, right? What about the front portion here? And what about the portion which is underneath? That also you need to monitor, right? So what we have told is, anyways, you don't have robots to pick these. This warehouse wasn't that mature, right? So we told you'll have 2 people, 1 person here, 1 person there standing to move these. So we requested these workers to just lift this pallet like that. If you lift the pallet, this is how the pallet will be. Then this camera will see this portion, which is the bottom portion. And this camera will see the front portion or the top portion of the pallet. And then that information also will come up on the screen. And here on the screen, it will say whether you have to move this pallet to the good zone, take it, carry it, and put it here. You place all the good pallets here, maybe, right? Or should this pallet be moved to this zone where you place all those pallets which need repair? Or would you move this pallet to that region which is called as dismantle? Dismantle means those pallets which are beyond repair, damaged beyond repair. This is exactly what we have done. Now, what did we do here? What was that interesting? What was it that was interesting? We looked at right positions of cameras. We invested in the television set because real time it will be guiding the workers there to move this pallet to the appropriate region. Right? This actually helps. A solution of this kind helps. So you also need to think about business aspects. Okay, how do I ensure that all sides, both sides of the pallet is quickly monitored? Otherwise, people might say that I can as well manually inspect. Why do I need your AI solution, right? Okay, a few other projects, very interesting projects are there in this.
Excuse me,
We'll
sir.
talk. Just a moment. So sorry. Okay, so a few more projects quickly we are going to discuss, and then we will proceed further. There is something called as bar bending schedule. I'll talk about this specific project now. And remember, always we need to get started with understanding the business problem. Then we will proceed further. So here, these are all called as the drawings. People have construction drawings, by the way. People have to manually look at these drawings and they have to create an Excel sheet. And in the Excel sheet, they have to mention how many steel rods are needed, what is the diameter of the steel rod that is needed, okay, what should be the length of the steel rods, what should be the shape of the steel rods. All these details, they have to look at this drawing and manually they need to enter into an Excel sheet. Sometimes this process takes close to 8 days. 8 hours if it's simple drawing, 8 days if it's a complicated drawing. And our solution that we have built, the moment you upload a drawing and click on process here, it would take probably 8 seconds and you'll be able to get this Excel sheet. This is the kind of automation, this is the kind of savings, cost savings, which are needed. Look at that. It took less than 8 seconds and all these details are extracted from that particular drawing. Okay, so you need to understand the business problem, that it's time consuming. You go collect a lot of drawings. From each of the drawing, again, you do annotation, train your algorithm, and we always deploy the algorithms on cloud, right? So this is on a local host, but ideally for the customer, we place it there. So when customer opens that particular URL, this is the kind of screen that they see. They just need to browse files, upload the images, click on process, job done. Okay, it saves huge amount of time. Then steel pipe automation. Okay, same thing. Now I think it'll be faster. Okay, that's for some person branding. I would have done this. Yeah. So in this way, the business problem here was that whenever a customer, raises an invoice, right? Customer places an order, places an order. They might say that I want 100 square pipes and I would need 200 rectangular pipes, so on and so forth. Yeah. By taking this order, this pipe manufacturer would then supply all these in a truck. But the workers, when they load the pipe, they might not accurately count on how many pipes they've uploaded. or even if they manually do it, it's a huge time consuming process, right? They manually inspect whether the right quantity of steel pipes are uploaded onto the truck or not. And then you transport it to the customer, send it to the customer. At customers' end, when they count, they might say that, hey, I ordered for 100 square pipes, you sent me only 98. I ordered 200 rectangular pipes, you sent me only 198. Possible. But if you have the image captured, and if this image is supplied to the artificial intelligence algorithm, AI solution, which will automatically count, which will automatically count the number of, steel pipes, and automatically, if it does a comparison, first of all, it will count and place that data in a database. Okay. And then it also automatically does a comparison with the invoice. In the invoice, it will be clearly listed on how many square pipes, how many rectangular pipes, how many pipes are needed by the customer. So this image you capture, you take using your mobile, then automatically counting happens. Automatically, it does a comparison with the invoicing system. And only then the truck leaves the premise. Only then the truck leaves the manufacturing unit and then supplies it to the customer. All this is going to help. Yeah. All this is going to help immensely. This is one of the solutions. Then we have done projects in the space of life sciences, healthcare also. This is one of the interesting projects that we have accomplished. I would certainly explain more about this. Okay. What did we do as part of this project? And what is this project, right? Once again, we need to start with what? Business problem. What is a business problem here? Because of the changing environment, a lot of people are having difficulty in naturally having babies. Okay. And those people who are not having babies naturally, they go for a treatment called as IVF, in vitro fertilization, where they take the sperm from the male and they take the oocyte from female. They fertilize these two outside to form something called as oocyte. Okay. They fertilize outside, which is called as embryo, my bad. Okay. So they take the sperm, they take oocyte from female, they fertilize outside to form something called as embryo. This embryo is then implanted into the woman's womb. Okay. Then after a few days, the woman would realize whether she is pregnant or not. If not pregnant, then this cycle repeats. Cycle of IVF repeats. And if the cycle of IVF repeats, it's going to cost you, and it's also going to have a mental strain on your health. Because each time embryo is again implanted, woman has to wait to figure out whether she is pregnant or not. That causes a lot of mental stress. Will I become pregnant or not? What if I'm not? Another cycle of IVF. Oh my God, it's going to be costly. All these things keep, wobbling in the brain. Hence, we came up with this is the business problem, by the way. Yeah. Once you understand the business problem, what do you do next? Once you understand the business problem, you go and collect the data collection. As part of that, you take these embryo images, and here for annotation on which embryo is good, which embryo is bad. In order to get that annotation, you need to take help from doctors. They have to help you. This annotation or labeling is a very costly affair. You need the doctor support, physician support. Otherwise, you'll not be able to take it further. Then you supply to your machine learning algorithm, which will learn the patterns on what kind of images are good, what kind of images are bad. Then you go and deploy the solution. We deployed the solution on cloud. We normally use AWS because we have expertise, deep expertise rather on that. We sometimes also use Microsoft Azure and GCP, but majorly it's AWS. Then the end customer, doctor, physician, will only open the URL, website URL. And they will browse and upload this particular image. The moment they upload the image, like this, they'll click on browse files and they'll upload the image. The moment they upload the image, you will get a report with viability score. Okay, I'll show that. It will just scroll down. What would happen is these doctors will get a viability report. Means what is the probability that it is bad? What is the probability that it is good? Okay, and the final report says bad here. That means don't go ahead with implanting this embryo into the woman's womb. It would not be successful. It would not be a success. So this way, what is happening? You are ensuring that your AI solution acts as a help, right? It is going to act as an assistant to the doctor, assistant to doctors. Okay. And only those embryo which have high probability score of being a success would be implanted into the woman's womb. This will ensure that the number of IVF cycles is reduced, and it will cause significantly less mental strain on the health of the the people who want babies. Okay, so this is how you can make things really, really interesting. Okay, so there are a lot of such use cases, a lot of such projects, but we'll discuss. Okay, now let's look at a few more things. This is all about pallet counting. We have already seen similar kind of thing, the damage thing, right? Here we have another project which is all about extracting the data from your invoices and then doing a quick comparison. Then we have pharma forecasting and all that. So I take less time from here on because there are quite a few projects which I need to, explain. So anyways, let me explain this part. I'll explain the business problem as well. Now, this is a project which we have done for one of the startups, right, which is in the space of e-commerce. This also should give you information that artificial intelligence is industry agnostic. AI is not specific to any industry as such, right? AI can be implemented to all the industries. Okay. So here you go to probably, companies, some e-commerce store, like what example do I give which matches the global audience as well, right? Like Walmart, right? Um, DMart. In that way, there are a lot of, not just e-commerce, there are a lot of retail stores, big retail outlets. You go and purchase, say, your big retail stores. You go there and say you purchase household items. Then what do you get? You get a bill. Okay. And this e-commerce company was facing an issue wherein they wanted to give customers an option to do a comparison, okay, between comparison of prices between other retail companies versus theirs. Okay, they wanted the customers to, manually enter all the goods that you purchased, what was the price of each of those goods, and they wanted uh, the customers to do a quick comparison between the prices of the goods that they purchased from, say, Walmart with the goods that, I mean, if purchased from their company, how much money they would have saved. Right? So they wanted customers to do this kind of a comparison where you have the name of the products, whatever, rice bag, for example, 5 kg rice bag, for example, say you purchased. What was the price when you purchased in Walmart? Maybe the price was $10. This is an example. Price at, say, Walmart. The same item, if you would have purchased at this company, I'll hide the name of the company. I'll call it as startup. Then you would have gotten that for $9.50, and then you would have saved 50 cents. Right? You would have saved 50 cents. This kind of report they wanted to give to the customers. However, the expectation was that customers have to manually enter the details of these products and the price. Only then this information would come up. These two fields customer has to enter manually, and these two would automatically get populated because these prices you'll get it from the database of this startup. This startup maintains a database in which you'll have a table. In that table, you'll have list of all the items and what is the price of those items. Okay, so from here it will pick up this. Okay, rice bag 5 kgs. What is the price of that? It will pick up and show here, and then it will show you the difference. Yeah. Manually, who is that customer who would sit and enter the details of all these items and the prices of these items? Who would do that? Not many people will do that, right? So what did we do then? We have created a solution where our solution would automatically extract the details from those bills. Let's see. We have used a lot of object character recognition techniques, which are all called as deep learning models. All that is not that important. The way it's processed, that is important, right? Let's have a look at this. That part got mutated. Okay, you can browse. This is the kind of interface customers get. But you as a customer, you can just take a photo of the invoice. Okay, you just upload. All these things are not needed as an end customer. You need not put all these details. You just click on process invoice, and then it will process that particular invoice. It would extract the details, and this is how it would extract the details: bill date, bill number, product name, bill quantity, unit price. And then it will do a comparison, and it will tell you that if you would have purchased all these items from me, from this startup, then it would have saved you, probably $1, $2, whatever. Okay. Then we have built a project in the space of forecasting, right? In the forecasting, what happens is, again, I'm just skipping a few things such as business problem and all that. Or let me explain the business problem. Business problem was that this particular hospital, has a pharmacy within. Okay. This pharmacy would stock the drugs. That is what any pharmacy does, right? It will stock the drugs. Vital drugs, essential drugs, desired drugs, so on and so forth. Sometimes they overstock. What will happen if you overstock? If those drugs reach the expiry, you lose money. You'll not get anything. You just need to throw those drugs. If you later on realize that these drugs I don't need, and if you return it to the pharmacy, or if you return it to the pharmaceutical company which manufactures, you get some money as refund, not complete money, some money. How much money would you get as refund depends on how many days are left before the drug expires. The more days, more money you get back, right? So that's a problem with respect to overstock. What is the problem with respect to understocking? If you keep less drugs than needed, then whenever a patient comes to you and asks whether you have those drugs or not, you'd cut a sorry face. You'll say, no, we don't have these drugs. Sorry. Customers will be unhappy. Patients will be unhappy. So overstocking is also a problem. Understocking is also a problem. So what we have done is we have collected the names of the drugs, the date and time, which date, at what time, which drug was sold, what was the price of those drugs. Then we shortlisted those drugs which are very costly, those drugs which are really essential, should have in your hospital. And then we built a forecasting model to look at seasonality, trends, and all that. So date and time will give you a lot of details such as season, summer season, winter season, rainy season. Whenever seasons change, people tend to, body of a few people doesn't adjust quickly. That is when they'll have fever, flu, so on and so forth. Right. So all those kind of details we capture from date and time. And then you have drug price, how many drugs were getting sold day on day. With all these details, we built a forecasting model. From there on, this hospital started using the forecasting model, which forecasts on how many vital drugs do you need, how many essential drugs do you need, how many desired drugs do you need day on day. Okay. And this helped, stock appropriate number of drugs in the pharmacy so that overstocking issues addressed and understocking issues addressed. So using our AI solution, they forecasted on what is the right stock that has to be maintained in the pharmacy. Okay. Then a lot of such projects, for instance, cement inventory forecasting. How many cement bags should I have in different regions? Because that will help you determine how much quantity of cement you have to manufacture. Okay. Then we looked at cement quality assurance. I'll talk about this aspect as well. Then we will talk about the generative AI. So here, when it comes to the cement quality, when the cement was manufacturing, people have taken a lot of raw materials, such as they take fly ash, they take gypsum, right, clinker, all these things as raw materials, and then they send it to the manufacturing component. You'll have, rollers, grinders, and all that, right? Then you get cement. This cement would continuously be manufactured. And the quality of the cement is measured using something called as microns. Okay, that's how the quality of the cement is measured. So people were manually taking this cement, the small sample of cement, every hour. Sample was taken every hour. And this sample was sent to lab. Why do you send it to lab? To test quality. So manually they inspect the quality of the cement every hour. And if the quality is bad, what happens? If the quality is bad, then you throw the complete cement which was manufactured for the last 1 hour. Okay, the raw materials which were used to produce that cement is gone, waste. Time that you spent manufacturing is also gone. Loss making process, right? If you figure out that the quality of the cement is not right, for the last 1 hour, whatever raw material you put, whatever finished product you got, cement, whatever effort you would have spent, electricity that you would have consumed in terms of running the manufacturing unit, everything is gone. So what we have done is we have collected the data from all these sensors, the quantity of raw material which was supplied, date, time. Okay. Then we have collected all the details such as fly ash, gypsum, clinker, the other sensors, the rotation speed of the grinding machines, ball mills, etc. We took all of those and then we started capturing the details on whether the cement quality was good or bad. Manually, when I've done lab inspection, was it good or bad? When it was good, what were the values of different sensors and the raw material which was used? What component or how much quantity of raw material was supplied? And when the cement quality was bad, what were the different sensor values and raw material values, so on and so forth. Then we supplied this data to our AI algorithm, which would learn the patterns. And when we deployed it, this data was getting captured every minute, right? So every minute, as soon as we get the details of all the sensors, We have given it to our AI algorithm, which would quickly tell whether the quality of the cement is good or bad. Continuously, real time, we were monitoring this. Okay. I'll come to the generative AI project in a quick moment. We have done generative AI projects also for different customers and a lot of things. Our AI tutor, which is the learning management system which we built, is also generative AI driven. Then this is again in the space of degradable versus biodegradable waste. In this way, there are a lot of projects. Let me take quick 5 minutes. I'll explain this and then we'll get to generative AI stuff. So here, whenever you collect the waste from garbage from the bins, you can figure out what quantity of this garbage is non-biodegradable. Okay. And what is the contamination percentage you would come to know. You just supply the image, our algorithm will classify and tell you whether the contamination percentage is more than desired or not. Anyways, I'll not talk more about this because now it's high time that we get into the generative AI and AI discussion, and then I'll explain about generative AI projects. All right. Finally, we are there. Huh? Finally. Okay. Now you understand what is artificial intelligence, right? What is AI? AI is all about automating human intelligence. All these projects that I've shown you, had a human element. So humans can do all those things, right? Whatever activities humans can do, okay. If you can automate that artificially, the human intelligence, like in the truck, if incorrect clamping sequence is followed, you can determine, right? Manually, you can check whether right sequence is being followed or not. The embryo project, manually doctors can put that image under the microscope and determine whether it's good or bad. Manually, you can do it using human intelligence. If you can automate that, it becomes artificial intelligence. Simple. Automation of human intelligence is artificial intelligence. To build AI applications, you need knowledge about data science. Data science is all about understanding what is the business problem. What is the right kind of data that you need to collect? How do you need to annotate the data or pre-process the data? Okay. All that is part of data science. And within data science, you have a special subject, which is called as machine learning. Machine learning is all about learning the patterns in your data, be it videos or images or textual data. Within machine learning, there is a special branch which is called as deep learning. When you deal with images, video, textual data, etc., people use deep learning algorithms, which is a special subset of algorithms. These are also part of machine learning, but special. That's why they are separately placed as deep learning. Okay. Now comes generative AI. What is generative AI? As the name itself says, generative AI is all about generating new things. You can generate videos. You can generate images. You can generate audio. You can generate text. All these things can be generated. But how do you use the concepts of generative AI for the real world. This part is more important, isn't it? This is more interesting. And I'm going to come up with additional hours of videos on generative AI to help you exactly understand the history on how this generative AI evolved. What do you mean by large language models, large visual models, large multimodal models? What is prompt engineering? All of that, in a detailed manner, you'll anyways understand by watching those videos. But for now, I'll only explain about the applications and what kind of applications we built when it came to generative AI world. Okay, so we'll talk about a few of the projects we have done in the space of generative AI. And again, we'll try to understand the business problem and how do you go about at a high level. Yeah, how do you go about solving that? So we have done a project for a customer, and this specific client is a startup in the space of life sciences healthcare called as Setup. Like stethoscope, you have Setup. Okay. So we try to understand on what are a few of the areas where we really need generative AI, and we figure out that one key business problem was in terms of writing referral letters, discharge summary, etc. So what happens is if you're a patient, say you're a patient, and say there is a doctor, okay, and if the doctor wants to move you to a different department from say general ward to a department where they do some kind of oncology or some kind of cancer treatment. Yeah, I'm just giving some rare examples. So this doctor has to write a referral letter and refer you to a different department. Doctor has to write. In a lot of hospitals, trust me, doctors write manually. They'll take a pen, they'll take a paper, they write the referral letter. In some cases, there is a standard format. Still, they have to write. Maybe in that particular referral letter, it will be written as patient name. But name, doctor has to write, right? Age, doctor has to write. Description, there will be a field called description, but the entire description should be written by the doctor. Manual process. And majority of the times, these referral letters are written bearing in mind the hospital process. Every hospital will have its own process. Within how much time the patient should be transferred to another department. In that way, there'll be a standard process. This process has to be followed. Not just referral letter. When you're discharged from the hospital, discharge summary has to be written. Doctor has to give you a discharge summary. This patient was suffering from these issues. Now we are discharging because the patient is stable, right? And these are the various parameters in that way. Here also there'll be a process. The way you have to write the discharge summary, what are the key elements that you have to include? It varies from hospital to hospital based on their processes. And also after you're discharged, you need some guidance, right? You'll ask the doctor, what should I eat? Can I eat anything and everything? Can I exercise? For how long? So on and so forth. That's called as post discharge instructions. In this way, at every walk, there will be some certain number of documents in a specific format that the doctors, physicians, or hospital management has to generate. They have to either manually write or they have to type and then take a printout, because every patient is not the same. Every case is not the same. The kind of disease I have versus the kind of disease you have would be different. So there's a lot of manual process going on here. And the person who's writing should also be writing these referral letters or discharge summary or post-discharge instructions. They should also be well versed with the internal hospital processes. Remember all these things, manually do it. So we thought, let's do one thing. Generative AI is something that we have to start using. There are a lot of generative AI, large language models. It's called as large language model because it's trained on huge amount of data. And a lot of medical literature data is also taken. Medical literature data is taken. And there are a lot of LLMs which are built on that. Like you have BioGPT, BioBert, PubMed, GPT, so on and so forth. A lot of, LLMs, large language models are built. Large data set, language, English language, and other language, but we are talking about English predominantly here. Models or machine learning models. However, these models are trained on general literature, generic medical literature. On that, you can readily use those large language models. However, you have your hospital process also. Country-specific processes also exist. You have to take all that literature and then you have to ensure that your large language models, which are trained on generic data, which is available on internet, you have to take those models and you also need to teach those models your process. Okay, teaching your process related stuff to the large language models is also needed. This process is called as fine tuning. You fine tune. Okay. And once you fine tune, then you get a large language model, which is not just trained on the general medical literature available on internet, but also it is trained on your hospital process. Now, this LLM can be used by your hospital staff, by the healthcare professionals, right? And let me open this and show you. This is a bot. You people can experiment. It is live in action. So when you people get trained through us, you'll be learning real world projects. You'll be working on real world projects, right? I believe no one in the industry is doing that because all these projects are so critical. To work on these projects, you need to have intelligence. You need to have the team. Someone has to believe you and give these kind of projects. Why would big customers such as Volvo, Benz, Korean Airlines, Coca-Cola, etc., give you projects? They give you projects only if they trust you, that you have been there in the industry for long, you have been working on such projects. Only if you have the desired credentials, they will give you these kind of projects. And working on these kind of projects alone will help you get good knowledge, which will help you get a job. Otherwise, it's going to be very tricky. I doubt anyone just learning the technical stuff, theoretically, working on some dummy projects, would get a job. I doubt that. Okay. So with us, that's the advantage. Okay. Having said that, periodically I keep using the session for, sales pitch also. Excuse me for that. Okay. Now, all you can do is say, for example, you want to write a referral letter. Click on that. You get this referral letter. You put a medical condition. I think it will ask me to register. No, thankfully. So what would happen is, it will take less than 5 seconds and then it will give you a report like this. You need not type it. You just copy, paste, change wherever need be, job done. Right? In this way, we have created a lot of prompts. For example, discharge summary, post-discharge care instructions. And we have also given an option for someone to type. But how many of the doctors or healthcare professionals, or for that case, even AI experts, know how to type and ask a question? Typing and asking questions, right questions in the right format, is called as prompt engineering. It is called as prompt engineering. And prompt engineers, this is a profession. Oh my God, just typing some sentences and asking right questions. Is it a profession? Oh yeah, absolutely. It's an ocean. It's a very big thing. So let me quickly explain you all this thing. Prompt engineers salary. Okay. Oh, average salary is 40 lakhs per annum too. 154.9, that's 1.5 crores. Let's see. This is giving me Indian context, but then in US dollars, $335,000. Who gets paid? Prompt engineer. Oh my God. $70,000 to $100,000, 2.7 crores Indian rupees. Yeah. You can translate that to Malaysian ringgit also. $300,000. That is 1.2 million Malaysian ringgits. $335,000. Prompt engineers get paid. Right? So don't assume that just typing something will give you the right result. No. A lot of testing goes in. There is something called as chain of thoughts, tree of thoughts, and a lot of additional things exist when it comes to prompt engineering. By using those techniques, you have to figure out what is the right prompt which is going to give the right result. Okay. And we cannot expect the healthcare professionals or any other layperson to type a prompt in that way. So what we have done is we have thought through, we have experimented with a lot of prompts, and we have given a few prompts which people can just click and use it. The only thing that has to be changed is, say, medical condition. This is going to help, avoid unnecessary prompts being used. And usually your large language models will generate some text. Sometimes the text might be wrong also. That's called as hallucination. For example, if you teach your kid, say, 2 table, 2 twos are 4, 2 threes are 6, and then say you taught the 3 table as well, 3 threes are 9, and so on and so forth. And if you ask a question on 5 table, or say 7 table, okay, then since you didn't teach your kid 7 table or 5 table, they will imagine certain things. If you force your kid saying that, I don't know anything, I taught you 2 table and 3 table, now tell me what is 5 5 0. Now the kid will start hallucinating. 3 threes are 9, 2 twos are 4, 5 fives are must be 10 maybe. They'll hallucinate an answer, which is wrong. Which is wrong, right? The same thing happens with your large language models also. When you ask a question which is pretty irrelevant and your model was never trained on such things, it will hallucinate and gives these kind of results. And in healthcare, if you're going to give wrong result, wrong referral letter, wrong discharge summary, wrong instructions, then you'll be in for trouble because it's about lives of humans. So it always makes sense that you give certain prompts which people will readily use and put a disclaimer saying that if you're going to use any other prompt other than the prompts which are given here, if you want a free flowing prompt or question that you want to ask, go ahead. But the model might give you incorrect results also. So you manually read and use your intelligence. Yeah. Hence, one more thing is generative AI or AI for that case cannot be a replacement to the humans. It can only be a supplement. Very important. Okay, people assume that, oh my God, I'll lose my job and all that. No. Use it as a friend. Use AI or generative AI as your friend, and then you'll start reaping benefits. Another project that we have done is for one of the government organizations where we trained the large language model. We have taken a large language model called as Palm 2, which is open source. And then we have used that large language model, which is open source, and we have fine-tuned it. We have fine-tuned using government orders, gazettes, which are big policy documents, right? These policy documents, etc., run into 180 pages, 190 pages. If you want to ask a question, for example, say there is investment policy. Investment policy document. This policy document says for 180 pages. If there is a person who wants to become an investor, he wants to come to your country and invest, then are you going to tell to this person that, hey, you have 180 pages, read it? Right? It's very difficult because these are all business owners, flush with money, and they would not be interested to read all the 180 pages. So what we have done is we have taken all these policy documents, etc., and we trained this model. Open source large language model is already trained on internet data which is publicly available. Now, government orders and gazettes, your large language models are not trained on these documents, these government documents. So we have taken these government documents and we fine-tune. Fine-tuning means training your large language model on these documents also. It's called as fine-tuning. Then we gave a bot wherein you can just ask questions. What is the tax rate if I want to come and invest in your country? What is the corporate tax rate? What are the various, investment guidelines which I need to follow before coming to your country to invest? In that way, people can ask questions before coming to your state and investing. Okay. What are the other perks and benefits that I get as an investor if I were to invest in your state, in solar plant, for example? You can ask such questions and it's going to pull the relevant information from these documents and give it to you, as opposed to you reading all the 180-page documents. So these kind of projects and many more we have done, and you can always read the benefits. Okay, what is the MOU target? Right, details about a specific policy, investment policy. We have also given a few prompts for people to quickly just click and ask questions. What incentives are provided for investment? The incentives provided are ABCD XYZ. Okay, so in that way, you can make your life very easy and very simple using the concepts of AI and generative AI. Hope you enjoyed this specific work, the specific discussion which we had until now. And what I wish to do now is just give you some details for you to connect with me if you want to, of course. And yeah. For any project related discussion, etc., you can drop an email on Bharani at aisprite.com, or you can scan this QR code and follow me on LinkedIn and ask questions there as well. I'll be more than happy to answer. And I would be very soon coming up with maybe a few hours of lectures on generative AI to give you a workflow on how to handle generative AI projects end to end. Yeah. Hope this helps and hope this helped. Thank you so much once again for being patient. And thank you all so much.